Question number 9. 54k squared minus 6 all divided by 3k plus 1.
Anytime you are confronted with a question like this, the first thing that comes to mind is that we are expected to factorize each of these numerator and denominator where factorization is applicable. So obviously from this question, 54k squared minus 6 is easily factorizable. We can see from the two terms, this and this, we can see that 6 is common to them. So we first and foremost factor out that 6. So we have 6 into, by the time we write this, we have 9k squared minus 1 all over 3k plus 1. Now obviously looking into the content of this bracket, you will obviously observe that the two terms here, they are each perfect squares. That is to say, we may write each of them as something squared, another thing squared, where those two things, they are rational statements. So we have here 6 into 3k squared minus 1 squared over 3k plus 1. Obviously, the denominator here is not further factorizable. So it's going to be like that throughout until we get rid of it somehow. Now, every stage of difference of two squares, that is, anytime we have something like a squared minus b squared, what should come to mind in order to factorize this is to write a plus b into a minus b. So every mathematics student must know and acknowledge this fact. Anytime you see two values that are squared, each of them squared, and there is subtraction in between them, what should come to mind is that the statement is factorizable, and this, of course, is the factorization. So that is applicable here, so that this will be like our a that is squared, and this is like our b that is squared. So we are going to have, therefore, our next statement that we read as 6 into 3k, that's our a plus b into a minus b, bracket closed, and this is over 3k plus 1. Now obviously we can see that this statement and this statement, they are similar, and therefore they cancel out, leaving us with 6 into 3k minus 1, which is our final answer. However, we may as well write this as 18k minus 6 if we so choose to open the bracket. So any of these could be our final solution.
Question number 10. Represent the inequality minus 7 is less than 4x plus 9 is less than or equal to 13 on a number line. This question is asking us to draw the number line of this inequality. So we have to solve the two inequalities that are involved, because obviously you can see that there are two inequalities that are here, this one and this one, that are highlighted there. Now therefore, what we do is to separate the two inequalities and solve them independently. Then we combine them together in order to form the final solution inequality, and thereafter draw the required number line. So here we go. The two inequalities involved are minus 7 is less than 4x plus 9, and of course 4x plus 9 is less than or equal to 13. So these are the inequalities that we are going to solve independently. So we have here on this left side, minus 7 is less than 4x plus 9. We transfer this 9 to the left hand side so that we have minus 7 minus 9 is less than 4x. And of course, this gives us minus 16 is less than 4x. And we divide both sides by this 4 in order to isolate the variable x. And because the value 4 that we are going to use to divide both sides in order to isolate x is a positive number, the inequality will not be tampered with, so it will be retained. So we have minus 16 divided by 4 is less than 4x divided by 4. This cancel out, and of course 4 goes here 4 times. So we have our final statement here to be minus 4 is less than x, and that ends the solution to that inequality there. So we move to the right hand side here, and we have 4x. Transferring the plus 9 to the other side gives us less than or equal to 13 minus 9. Okay, so we have here 4x is less than or equal to 4. That is 13 minus 9. Now again we divide both sides by this positive 4 to get 4x divided by 4 is less than or equal to 4 divided by 4. So these cancel out, these also cancel out to 1, so that we have our final statement here to be x is less than or equal to 1. So these two final inequalities we are now going to combine to form one single inequality, so that we have minus 4 is less than x, and that same x is what is less than or equal to 1, combining the right hand side and the left hand side final inequalities together. So having obtained this final inequality solution, so we now draw the required number line. So here we have the horizontal line drawn like this, and we have on this left minus 4, and on the right positive 1. Now we draw a small o on top of each of these two boundary values. Now, for the reason of this inequality being a strict one, strict in the sense that there is no equality in it, so it is strictly less than. So this O here is going to be left very open. It is going to be left open. That is open, that it is not shaded inside. On the other hand, the other one, this one, is going to be shaded because this inequality has equality with it. There is equality sign here. So that makes us to have to shade this center here. And that is very important. Now we will draw a line to connect them. And the variable here is variable x. And of course, this is the final statement of what we are required to draw.
Question number 11. Make P the subject of the relation Q is equal to 3P over R plus S over 2. Because it is letter P that we are expected to make the subject of this relation, then it means all we will try to do here is to isolate the letter P. Now clearly we can see that the letter P is contained in this term. So that means the other term, this one, is the one that we are going to shift to the left side of the equality sign. So that is the first step we are going to take, so that we have Q minus S over 2 is equal to 3P over R. Now we know that by multiplying both sides of the relation as it is now by R, we are going to have only 3P on the right side of the relation statement. So that is exactly what we are going to do, so that this R will be removed from this entire term. So here we go. Multiplying both sides by letter R, we have R times Q, we have RQ minus RS over 2 is equal to 3P, because the R will have cancelled out the R below. So we have now this 3 to eliminate, so that P will be completely isolated as is required by the question. So here we go. We divide both sides of this equation by 3, so that we have RQ over 3 minus RS over 3, and that will multiply the 2 that is already there is equal to P, because the 3 we are using to divide through will have cancelled out this 3. So now we have P giving us R cubed over 3 minus RS over 6. This may be our final result, but we may choose to put everything together as a single fraction on the right hand side of the equation, so that we have P being equal to the LCM of the denominators will be 6. 3 is 6, that is 2. 2 times R cubed will be 2R cubed. And 6 is 6, that is 1. 1 times minus RS gives us minus RS. This may be another way of writing our statement. However, another way of doing it again is to say this P is still equal to, having identified that this R and this R are common to all the terms in this numerator, we therefore factor it out so that we have this common R outside. So we have 2 cubed remaining minus only S on this side. So this will be everything over 6. So any of these 3 ways will be the way to put our final solution.
If x plus y is equal to 2y minus x plus 1 is equal to 5, find the value of x.
In this question here, there are 2 linear equations which are x plus y is equal to 2y minus x plus 1, while the other one is equation 2y minus x plus 1 is equal to 5. So we are going to solve the 2 equations simultaneously. So the first thing we do, trying to solve the one on this left side first, is to put together all the like terms, and of course the variables x and y will be on the left and the constant term will be on the right. So we have x plus x, that is carrying the minus x here to the left. That gives us what we have just written, and we have plus y minus 2y, doing a similar thing to the 2y on the right hand side, is equal to the positive 1 that remains on the right hand side. So that leads us to getting 2x minus y. Y minus 2y will be minus y is equal to 1. We may refer to this as our equation star. Now we go to the right hand side and we have minus x plus 2y. What we are trying to do here is to write the x variable first, because that is what is on this left hand side. It is the x variable that is written first here. So we are doing a similar thing on the right hand side, and of course we take the constant term to the right hand side, so that we have 5, the 1 is changing to minus 1. So here we have minus x plus 2y is equal to 4. So we may call this our equation star star, just for identity purpose. Now we are going to solve the two equations simultaneously. Now we may choose to use elimination method here, so that we have 2x minus y is equal to 1. That is our equation star. Then by multiplying this equation double star, by multiplying this equation by 2, we have minus 2x, that is 2 times minus x, then 2 times plus 2y will give us plus 4y is equal to 2 times 4 will give us 8. So we may call this star star star. Now we add this together. We are going to add because this variable x that we wish to eliminate here, they have opposite signs. If the variable that you are to eliminate, if they have different signs in the sense that the 2 here is a positive 2, while the 2 here is a negative 2. So in such situation, what you do is to add the two equations together. If they have the same signs, you subtract. So we go on and we say 2x plus negative 2x, that will give nothing, they will cancel themselves. And when we add also minus y and 4y, we get 3y. And 1 plus 8 will give us 9. So we have dividing both sides by 3 in order to isolate y gives us y being equal to 3 here 1, 3 here 3. So y is equal to 3. So that's our first variable that we are getting. And we pick any of the previous equations, whether the one with star or double star or triple star, whichever one we desire. We pick any one of them. Let's assume we pick this one, the one with 1 star. Let's assume that's the choice that we made. So in that case, we have 2x minus y is equal to 1. Now, but we know that y is equal to 3. We have just obtained that. So we substitute into equation star to get 2x minus y, or y is 3 now, is equal to 1. So that we have here 2x is equal to, when this one goes to the right hand side, we have 1. The minus 3 is changing to plus 3. So we have 2x is equal to 4. And of course, that makes us to have, dividing both sides by 2, leads us to getting our x to be 2. So we may just summarily put the 2 together, that x is equal to 2 and y is equal to 3, according to what we obtained here earlier. So these are the expected values of x and y that are required.